All right, I want to start with graphing an absolute value function. And to do that, first I'm going to start with y is equal to x, which is just a straight line. Now, y is equal to x is a straight line that goes through the origin that looks like this. We could also write it as f of x is equal to x. Remember, whenever you have the y and the f of x for a function, those are interchangeable. Now, what you're going to do when you have an absolute value function is an absolute value function means that everything that is negative becomes positive. So for this, I would be saying y is equal to the absolute value of x, which basically means anything that is negative becomes positive, and what ends up happening is it becomes a v, and this x-axis acts like a mirror and just bounces it back up in the other direction. So it would look like this. And this is the graph of f of x is equal to the absolute value of x. And when I'm talking about this graph, it's important that we note what this point is. This is called the vertex of the point, and in this case, this is a minimum value, which means it's the lowest point on the graph. Now, if this graph gets reflected and I have y is equal to negative absolute value of x, then all of this shifts down. I should have said reflects down, and this is the graph of my function is equal to negative the absolute value of x. All the same transformations that we've talked about before will happen when you're doing with absolute values. Let's go ahead and review them quickly. All right, a couple things to know about this. Whenever you have a graph that is in this form, the vertex will be HK. The axis of symmetry is x is equal to h. If a is greater than 0, it opens up. And greater than 0 is just another way of saying it's positive. If a is less than 0, the function will open down. And a little bit more about some of those transformations. And some more about a. If a is between -1 and 1, the graph is wider. If it is larger than 1 or smaller than -1, the graph is narrower. We're going to talk about h and k a little bit more next. H and k translates the graph to left and right and up and down. All right, so let's start with the vertex, and let's explain why the vertex formula works the way it does. What I want to think about is taking the inside of the absolute value equation and asking myself, where does it equal 0? What values of x will make the inside of the absolute value 0? In this case, it's always going to be the opposite of what the sign is. If this is a +2, well then, if it was -2 plus 2, that would be the absolute value inside equals 0, or you can think about it as where does x plus 2 equal 0, and that happens at -2. All right, that is our vertex. Our x value for our vertex is -2. It also tells us that this is a shift 2 places to the left. And that's why it's always the opposite of what you see on the inside of the transformation. Now, what is the y value of the vertex? Well, the y value of the vertex is just whatever is left over. So in this case, it is just +3. And that +3 also is our shift up 3 units. So that gives us a vertex of -2. So I go over 2 units from the origin, I go over 1, 2, and up 1, 2, 3. That puts the vertex right here. Now, how about, do I know if it's going up or down? Well, I look to my equation. There's nothing here, so that's understood to be a +1. So I do know that this is going up. How wide or narrow it is, I think it's better to err on the side of caution. Let's go ahead and do a test value inside here. So let's just plug in my opinion, 0 is the easiest one to plug in for x. And if I plug that in, that would just give us 0 plus 2 plus 3. The absolute value of 2 is just 2. So that gives us 2 plus 3, which is equal to 5. So I know at 0, I'm up here at 5. It's going to be symmetrical, so because at 0 is equal to 5, I also know 2 units in the other direction, which would be at -4, would also be at 5. So then my graph of this absolute value will look like this.